In addition to constant factor approximation algorithms, which we will look at in more detail soon, we are also going to be talking about advanced algorithms that are known as polynomial time approximation schemes. Scary term. And what the idea of a polynomial time approximation scheme is, it's a sort of more advanced constant factor approximation. So you can think of it as a sort of scale. And the idea behind a polynomial time approximation scheme is that the running time actually depends on the quality that you want to get. So with a constant factor approximation, you always get the same guarantee, say a factor 2 approximation. And in a polynomial time approximation scheme, you can more or less decide what the quality is that you want, but the better a guarantee you're demanding with respect to quality, the more running time you'll have to put into that algorithm. So it's a trade-off here. But first of all, let's look at constant factor approximation. We're now going to meet Alice again. Alice, as you know, is working on vertex cover, and so far I guess she has been the most lucky in this course because she seems to actually be working on a very well-behaved NP-complete problem. We also learned that there's good search trees, there's good pre-processing, and vertex cover was even fixed parameter tractable. So Alice can be quite optimistic about approximating vertex cover, and actually she has come up with two different ideas of how you could approximate vertex cover. Here are the two possible ideas that she has come up with. So the first algorithm takes as input a graph and then looks if some edges are still not covered in that graph, and if that is the case, it takes the uncovered edge and puts both of the endpoints of that edge into the vertex cover. And then the algorithm looks again if there's still some uncovered edges. If there are any of those, then it takes again one and puts both endpoints into the vertex cover, and so on until all edges are covered. And she calls that algorithm take two because it always takes two endpoints into the vertex cover each time you go through that loop until you're done. And here's her second idea, and she calls that idea greedy, because what that algorithm does, it's still the same in the first line here. It looks if some edges are uncovered. And then what it does is it goes through all of the vertices to determine which vertex could cover the most edges that are still uncovered. So which vertex is next to the most edges that have not yet an endpoint in the vertex cover, and then it puts that vertex into the vertex cover. So it kind of tries to maximize the coverage that it can achieve in each round that this loop here is run. So looking at the strategies of these two algorithms, what I would like you to think about for a moment here is, which of these two algorithms should we expect to perform better in terms of approximation quality? The one that always takes two endpoints, or the one that tries to maximize coverage?